Dear talents, welcome to the virtual learning platform of Sri Guru Sudhindra College. So here is a Java lab program number 11. This program is used to demonstrate the multi-threading concept. As you all are aware, so thread is a lightweight object, right? So the thread is called LWP, right? Lightweight process. Now here what we are doing is this program is specially used to demonstrate how this multiple threading concept it works. So at first let me give you the bird view of this entire program. In this program at first we are going to import the language class, the language package import java.lang.star. This program has got the multiple threads, first thread, second thread, there is a one more class called third thread. Okay, so there are three classes and these three classes are copy paste classes. Copy paste classes in the sense hardly there are slight differences, rest everything is same. The overview is the three basic classes, first thread, second thread, third thread, and there is a main class. That main class is called M thread, which stands for multi threading. Now let me show you the multi-threading class. Class M thread stands for multi-thread. Now here like in the general programs we have defined it. First thread T1 is equals to new first thread. So first thread is identified as T1, second thread is identified as T2, third thread is identified as T3. T1, T2, T3. T1 is the first thread, T2 is the second thread, T3 is the third thread. Now let us go through the first thread. Okay, what first thread is? This is the first thread. Class first thread. Okay, class first thread. First thread is name of the thread. It can be changed. Okay, so it is the name of a class. Anything can be quoted, but for basic understanding, for easy understanding, the name of the class is mentioned as first thread. Class first thread extends thread. Okay, so there is a class here called thread. This thread class we have not defined here. Okay, we have not defined because we are implementing thread function, so no need to define the thread. By default whatever is there we are accessing here. Fine. Class first thread extends thread. In this class I am using a method. What is the method? Method is run, public void run. Okay, run method is used to execute the thread. Okay, run method is used to execute the thread. First thread extends thread, public void run. Okay, in run what is used? One for loop. For I equals to 0, I is less than 4, I plus plus. This particular process is used just for the presentation purpose. Whichever loop, any number of loops can be added here. The counter can be edited as per the requirements. It can be updated. Fine. For I equals to 0, I is less than 4, I plus plus, print the value of I. So in generally if you print, what you are going to get? 0, 1, 2, 3, 4 is going to be the output of this. After displaying the output of the first thread, what I'm doing? I'm going to end it, right? For that particular purpose, I'll write this statement. First thread finished, or you can mention it as first thread has ended, or end of the first thread. However you want, you can frame the statement, no restrictions. Class first thread extends thread, public void run. In that run, one for loop is used. In that, the display statement. Then second thread, class second thread extends thread, public void run. For I equals to 0, less than 4, I plus plus, print I. So what's the difference in first thread and second thread? Here it is first thread, here we have mentioned it as second thread, here it is first thread, here it is second thread. Loop is same, value is same, everything is same. While ending, instead of mentioning first thread has finished, I am just mentioning second thread has ended. That's it. Again copy paste, third thread. Any number of threads can be added here, no restriction. For demonstration purpose, for understanding purpose, for easy understanding, only 3 threads are used. Same copy paste, in place of first thread, second thread, now we have mentioned third thread. And here in the display statement, I am going to mention it as third thread finished. Fine. Now, every thread has got a run method. every thread has got a run method. Fine. Now I need to call, I need to start it, I need to begin it. How to start? T1 start, T2 start, 3T, T3 start. As and when you write T1 start, the first thread it starts. T2 starts, the second thread starts. T3 starts, the third thread starts. Fine. So very interesting program, right? I'm very sure first for the first time you are witnessing such kind of an innovative or different kind of output, right? Okay. Now what is expected actually? How the program is written? First thread has got a loop 0 to 4 to be finished. After printing the number 0, 1, 2, 3, we need to display the line first thread finished. Then this, right? But what is happening here? You can just see here. 0, 1, 2, 3 is printed. Then again 0, 1, 2, 3 is printed. After that, second thread is finished. Then there is a message first thread finished. Then again 0, 1, 2, 3. Then there is a message third thread finished. Right? Okay. Now let me run it again. Okay. Now see the output here. 0, 1, 0, 1, 2, 3. Second thread finished. Then value got 2, 3. Then first thread finished. Then 0, 1, 2, 3. Then first thread finished. Now let me rerun again. 0, 1, 2, 3. First thread finished. 0, 1, 2, 3. 0, 1, 2, 3. Then again 0, 1. Third thread finished. Then 2, 3. Then second thread finished. What is happening here? For every run, so normally in the general program what happens is, as and when you run the program, for every run the output is going to be same, right? But here you can see 0, 1, 2, 3 first thread finished, 0, 1, 2, 3 third thread finished, then 0, 1, 2, 3 second thread finished. This is the speciality of the program on threads. This is called thread. Thread stand for the lightweight process, right? So in the parallel processing applications, this thread concept is used. The given program here, we are going to classify it into the smaller parts, right? The lightweight process, the smaller processes, we call it as LWP. And in this particular LWP, what is happening is first thread, second thread, and third thread. So what happens is, based on the availability of the processor's resources, this particular thread is executed. There is no compulsion that the first thread need to be completed, then second thread, then third thread, right? Either it can complete first one, second one, third one, or it can change the order, or it can complete a one particular thread, complete second one partial, third one partial. However it want, it can take, and entire thing, it depends on the processor time and the resources. So this is the speciality of the thread programming. In this thread programming, we don't have any kind of say, we don't have any kind of restrictions on how the output should be, and that entire output, it depends on that particular time's resource availability in the particular specific systems which you are using. I just tried it in the different systems. So for a moment the output was common for multiple runs, but for while recording this particular video, I'm witnessing for every run I'm getting a different kind of output, right? Let me show the output once again. Again I have executed. Okay, now again the output is different. 0, 1, 2, 3 first thread finished, 0, 1, 2, 3 again 0, 1, 2, 3, then third thread, then second thread. So this is the program on multi-threading. The multiple threads we are parallelly executing here. So 3 threads are used. So there is a copy paste method here, copy paste class, because copy paste class in the sense almost it is same. Here and there slight differences are there that need to be corrected. Then multiple threads, three threads are used, T1, T2, T3, and to begin the 3 threads we need to use T1, T2, T3. Start method is used. So this is about the thread function.